Good morning, my name is Samir Hott, a data science master's student, and this is Luke Miller, a computer science master's student. And today we're going to walk you through AlarmOracle.
So as a little bit of motivation, in 1979 at the 3 Mile Island nuclear power plant, a small valve in a secondary non-nuclear system failed to shut. This generated an alarm as it was supposed to do to alert the operator to fix the error. However, this alarm generated a secondary alarm in another system, which generated another alarm, which generated another alarm, and so on. This is called an alarm cascade. The operators at the nuclear power plant were faced with hundreds of alarms within minutes. Ultimately, this resulted in them not addressing the actual issue. The nuclear power plant melted down, radioactive gases and iodine released in the environment, and had the follow-on effect that in public opinion resulted in the halting of nuclear power generation in the United States through today, which means that coal-powered power plants have released millions of tons of carbon dioxide in its place.
So expanding off that a little bit, I wanted to take a look at the Piper Alpha oil rig situation. This is a similar situation where the operator had hundreds of alarms going off at the same time and just didn't know what to look at. And at this situation, there was no automatic shutdown for the platforms that were being affected, causing these massive fires and explosions and leading to over 167 lives lost in the situation. And connecting this to a little bit of modern day context, we still see things such as flash crashes, power network failures, and companies spending these thousands upon thousands of man hours trying to diagnose these alarms and find the best way to find the root cause of them.
Our solution to finding that root cause is called AlarmOracle. It's a graph neural network that uses Hawk's processes to identify the causal structures and network alarm data to find that root cause. That way the appropriate preventative action can be taken.
And so our data source came from a Huawei data set, but unfortunately we didn't find a testable target in our original data set, so we went ahead and generated data with a matching distribution. And with this, we built things such as device topologies and probabilistic alarms and used these to generate our alarm logs. And from here, we were able to create our data training model.
So AlarmOracle discovers the causal relationships in those alarm logs. That way it can identify these root causes. It uses concepts from graph theory, statistical learning, and many optimization techniques, specifically expectation maximization, Hawk's processes, and Poisson processes.
So explaining off that a little bit, our Poisson process actually does these without memory, and then our Hawk's process comes in and incorporates past events in order to measure future intensity of these events, and then our Dijkstra's comes in and measures the shortest k-step to the neighbors, and we're really focused a lot on AIC and BIC in order to optimize our data set and really make this early stopping a thing that we did in our set.
So our results, we achieved a 100% sensitivity rate. By that I mean that everything that we identified as an actual positive was positive. Now with that, we only actually identified about 50% of the potential alarm cascades. But it should be noted here that just because an alarm cascade potentially exists within the data set doesn't mean that it will be observed in the time window that we were able to evaluate.
So taking a look at our results here, we can see the green means true positive and gray means false negative. So the green would be something that the operator would need to look at immediately and try to figure out what's going on. Our gray would be something that the operator wouldn't see but could be a potential in our data set.
And building on what I said before, once again, we had 0% false positives. And this is key because just as these alarm cascades obfuscate or hide the source of what the operator needs to look at, a false positive would send the operator on a wild goose chase to find a root cause that doesn't exist.
And so, looking at our future directions, we'd like to better encapsulate our prior knowledge of this and refine our data pre-processing techniques in order to have a clean data set that we can start out with and start to model it a little bit better in order to have even a higher accuracy percentage.
And with that data pre-processing and other optimization techniques, we're not far from being able to have a real-time model that's able to adapt to new data in real time. Additionally, it'd be interesting to see this deployed in a real-world environment where we could incorporate the domain expertise of operators in the field for even better performance.
So we'd just like to thank you for listening to our presentation over AlarmOracle. Have a great day.